Hello everyone, in this lecture we will discuss about stick diagrams. What is a stick diagram? A stick diagram is nothing but a symbolic representation of CMOS layout design. So it is simply a rough figure of VLSI layout design. It shows how different layers such as metal, polysilicon, N diffusion and P diffusion are connected. But it doesn't show exactly what is the size and what is the distance among them. It is a simply rough design of a layout. It just shows the connection idea. For example, if you think in the right side figure, if it is a city, if you wanted to know what are the different roads, the roads are represented simply by the lines, but the exact dimensions of the roads cannot be seen or mentioned in the diagram. So stick diagram is such a rough figure which shows the lines used for different layers. So why do we use them? So we require stick diagrams for knowing transistor placement. So it shows where the PMOS and NMOS transistors are existed with respect to each other in the layout. And it also shows the layer connectivity. So it will give us how polysilicon, diffusion and metal layers are routed and connected with respect to one another. So here, in order to represent the stick diagram, different colors are used for these different layers. And also we are going to verify the pre-layout design by using stick diagrams. So the designers visualize the circuit before committing the actual layout geometry. So stick diagrams help us to do this. And also stick diagrams are useful for verifying the logic correctness. So it helps us whether the CMOS logic connections are correctly given or not in the design flow. So we will be using different colors for representing our layers in the stick diagram, so which is given by stick diagram layer conventions. So these are the different layers we are going to use in the CMOS layout design, and what are the representations of those layers, and the color we will use for drawing the stick diagrams is given here. So the layer metal is the main wiring layer for routing purpose. So it is mostly represented with the color blue. So polysilicon is mainly used for gate formation of the gate connections, so which is represented in the color of red. So N diffusion is used to show NMOS active region, and mostly it is used by the color green, whereas PMOS diffusion is useful to represent the PMOS active region, which is represented in the yellow. So contact cuts between whenever one layer crosses the another layer, we are going to define contact cuts, so which are generally represented as black dot, so in the stick diagram. And the power supply lines such as VDD and ground are represented either at the top or bottom of the stick diagram. So if you observe, the example figure of CMOS inverter is drawn here along with its stick diagram as well as layout. So in the CMOS inverter, so we have two different transistors. One is PMOS transistor, another one is NMOS transistor. So always the PMOS transistor is connected to power supply rail VDD, and the NMOS transistor is connected to ground. So both of the gate terminals are tied together, and we are going to apply the input, and the output is taken at the combination of drains of both of these transistors. So if you see the stick diagram represented here, the power supply rails are represented in the blue. So at the top VDD is represented, at the bottom ground is represented, and the active region of PMOS is represented by yellow, whereas N diffusion is represented by the green layer which is connected to the ground. And here the polysilicon gate, where the gates of both of these transistors are combined and the input is applied, is represented in red. and the output is taken from the drain. So it is nothing but a metal connection that is shown as blue. So there is a dashed line between PMOS and NMOS transistor. So it is represented in orange, which is nothing but the separation line drawn between PMOS and NMOS transistor respectively. And at the rightmost side you can see the detailed layout of stick diagram with the exact dimensions. So the core concept of transistor formation is polysilicon crosses the diffusion line. So a MOS transistor will be formed whenever polysilicon crosses a diffusion region. So the crossing point becomes the gate of that transistor with respect to that transistor. So if there is no crossing, that means there is no transistor at all. So the simple rule we must remember is polysilicon crosses the diffusion, so there comes a transistor. So the stick diagram arrangement must follow the way which is represented in the figure. So the order is represented from 1 to 5. So the first layer we are going to represent is always VDD, or nothing but positive power supply. So it is always represented at the topmost using the metal line. And second comes the PMOS network, which is nothing but a pull-up transistor which is in the pure diffusion. And the third comes the output node, which is a common node, that is nothing but drain. And we have a fourth arrangement which is nothing but NMOS network, so which is represented by pull down transistors in N diffusion. And at the last we have fifth layer arrangement, which is nothing but ground layer, that is the bottommost metal line represented in the figure. So the CMOS inverter stick diagram we have discussed just now is represented like this. So VDD, it is shown like this. So VDD at the topmost layer, so it is represented in the metal, and then comes a P diffusion, and then input is given at the combination of polysilicon gate, and output is taken from the drain common terminals, and before that we have a N diffusion, and then at the bottom we have a ground drain. So what are the things we must remember here are: a single vertical polysilicon line serves as the shared gate for the inputs of both transistors, and upper diffusion is nothing but P diffusion. This is always connected to power supply rail, positive power supply rail VDD, and the lower diffusion is N diffusion, and it is always connected to ground, and output is taken from common terminals of the drains where both of them meet. So here comes the most important rules of the stick diagrams. Whenever polysilicon crosses the diffusion, we have a transistor. So every gate is nothing but a crossing point. PMOS is always connected to VDD in CMOS inverter. So it is always above the output of a CMOS inverter. And always NMOS transistor comes or connected to ground. So where NMOS always sits below the output. Input is taken via polysilicon. Gate signals travels through polysilicon, and output is commonly taken at the drain where the both transistors share the common drain node. And metal for long runs is nothing but it is used for routing purpose. Similarly, the metal is used for metallic connections as well as contact link layers. So simply to say, stick diagram is not the final chip layout, it is simply a symbolic layout diagram that helps us understand the transistor placement, layer connections and CMOS logic before doing the actual physical layout.